Okay, so today's lesson is about experimental probability. Yesterday we talked about, we just called it probability. The kind of probability we were talking about yesterday was theoretical probability. And theoretical is just like we have a dice, we know how many numbers on it, so we can figure out what would be the probability of rolling a certain number. Sometimes we can't just figure it out from the situation. We have to do an experiment, and that's what experimental probability is like. We're going to learn how to find it. We also probably won't do number 3 today, where we use simulations to determine probability. We'll probably save number 3 for another day. Okay, experimental probability is probability that is based on either experimental data or observation. And when we find experimental probability, we really do it the same way as when we find theoretical probability. To find the probability of an event, we take the number of times the event occurs and we divide by the total number of trials. So it's the same idea as when we talked about probability yesterday, where we did the number of favorable outcomes over total outcomes. Favorable outcomes is just how many times the event occurs, and total number of trials is still total. Yes? Okay, I'll see that in a minute. Okay, so here's an example. You attempt 16 free throws in a basketball game. Your results are shown. What is the experimental probability of making a free throw? So we did an experiment here, or someone did some free throws. A 0 means that they missed, and a 1 means that they made the shot. So it's asking you for the experimental probability of making a free throw. So do we need to count the zeros or count the ones?
1.
Okay, so count how many
8.
ones are in that table. 8. Okay, so we have, let's write this out. We have how many free throws were made divided by the total number of trials, or in this case we'll just say attempts. Okay, so there were 8 free throws. How many attempted shots were there?
16.
Out of 16. So the probability is 8 out of 16. What does that reduce to?
1/2. No, 1/2.
1/2. Yeah, it's 16 divided by 8, not 16 minus 8. So 1/2. Probability is 50-50. This may be different. If we were to do my free throws, say I did 16 free throws, I might only get 3 of them. So the probability of me getting a free throw might be 3 out of 16. Maybe Jace here is really good at basketball. Maybe his probability would be like 11 out of 16 or something like that.
I'm actually pretty good at free throws.
All right, what is the theoretical probability that a baby born will be a girl? So we're going to look at a situation where we can find the theoretical probability, and then we're going to look at the experimental probability. So how many different possibilities are there? When a baby's born, it's one of 2 things, right?
No, a girl or a boy.
It's a girl or a boy. And I know in today's society we have a little bit of iffiness with all that, but we're just going to assume, for the sake of simplicity, okay, like back when this textbook was written, that the baby is either a boy or a girl. Okay, so we have 2 possible outcomes. Out of those 2 outcomes, how many of the outcomes are favorable? How many are girl?
Oh, really?
26 are girls.
No, forget this. Just out of the 2 possibilities, how many of them are the one we want? 1. Good. So the probability that any baby born will be a girl is 1 out of 2. It's a 50-50 chance, right? You're either going to have a boy or you're going to have a girl. Now let's take a look at some experimental data. Some experimental data. 54 babies were born at a hospital in April. 26 of them were girls. What is the experimental probability that a baby is a girl? Okay, raise your hand if you want to tell me how to set this up. Travis, give it a try.
Okay. So you do 54 and 26.
Which way?
You do 54 minus 26.
No. When we're finding probability, we are taking the number of favored events over the total.
Oh yeah, so you do 26 minus 50.
Okay, this
Did
doesn't,
you do it?
yeah, go ahead, Jenna.
26 and 54.
26
Yeah,
over
50.
54. Travis, what does it mean when we put a number over another number? What
Oh,
does
we
that
got
tell us?
divide.
Divide. Okay,
There we
so,
go.
does anyone have a calculator handy?
No, I'm sure. I got one. Oh, no.
I want you to do 26 divided by 54 and tell me what you get.
I need one.
Oh, it's the same thing as all the other ones.
6 divided by
54.
34. 34.
Mhm.
54. 50. Whoa.
What'd you get?
I like it.
Okay, so you got 0.481 repeating.
Whoa. I know.
Okay, what is, up here guys,
I'm up here.
what is the decimal for 1/2?
It would be
Jenna?
0.5.
0.5. Is 0.481 pretty close to 0.5?
Yes.
Yeah, usually with experimental probability, you're going to get a number that's close to the theoretical, but it's almost never going to be exact because real life doesn't work out that way. So you're almost never going to get exact. Let's look at an example with some dice. What is the theoretical probability of rolling a 2 on a die? So forget all this information down here, just look at this. What is the theoretical probability of rolling a 2 on a die? We had this in the warm-up. Tony?
3/6.
No.
1/6.
1/6. 1 out of 6. Okay, now, Gerda rolled a die 150 times. 28 of her rolls were 2. What is the experimental probability that Gerda will roll a 2? How am I going to find this?
150. There's 28 over 150.
Good. 28 over 150. Okay, do that on your calculator. Tell me what you get. 28 divided by 150. Tony?
186 repeated.
0.186 repeats?
186
Okay.
No, wait, 186. 6.
It's not repeating.
The 6 repeats. So it's 0.186. Just the 6 repeats, not the 0.18 part. Okay. What is the decimal for 1/6? Do that on your calculator and tell me what you get. That's okay.
6 says 1.
0.1?
1
Update them.
and 6 is repeating.
Okay. Are these numbers pretty close to each other?
Yes.
Yeah. So again, our experimental probability is close to the theoretical probability, but it's almost never going to be exact.
All right. Stop.
Okay, this is similar to what we did in the data section. We did some problems like this, where we wrote proportions and then figured them out. Remember that?
No.
It might come back to you here. A bicycle company checks a random sample of bikes. Out of the 400 bikes that were checked, 12 were defective. If the trend continues, what is the best prediction of the number of defective bikes in a batch of 1,300? So how do you think we would figure this out? Does anyone remember that? Jenna?
Put 12 over 400
Good.
and then x over 1,300 and then you cross multiply.
Good. Okay, so let's first talk about how we set this up. We had 12 that were defective out of a batch of 400. We want to know how many are defective out of a batch of 1,300. So that's what we put on this side.
I got it.
This way, guys, you got to raise your hand and wait till I call on you. We are cross multiplying. So we have 400 times x equals 1,300 times 12. What do we end up with, Taylor?
Oh wait, I divided it. Oops.
Jonah?
39.
39. We get x equals 39. So we can predict that there would be 39 defective bikes in a batch of 1,300. This is kind of like we can figure out the probability. We can say, listen up, 12 divided by 400 is what? Can someone do that?
Wait.
What's 12 divided by 400?
0.03.
0.03. So the chance
Jason's gonna try.
that a bike is going to be defective is 0.03. So is that likely or unlikely?
Unlikely.
It's unlikely. That's really small. That's a lot less than 1. So 39 bikes out of a batch of 1,300. If you go to Walmart and buy a bike, it's a pretty good chance that it's going to work. for most people, you're gonna get one that
Then you
works.
ride it in the bike.
Okay, this one asks us to predict the number of defective bikes in a batch of 3,500. Nick, how would you set this one up? We're still using the same setup on the left, so we've got 12 out of 400. What am I gonna put on the other side?
X equals 3, or X over
Good.
3,500.
Good, X over 3,500. Okay, do that, raise your hand when you get an answer. Hillary?
Wait, I'm doing 12 divided by
3,500 divided
This
by 12.
times, no, this times this, 12 times 3,500. Start this again. Okay, so when you're doing this on the calculator, you're gonna do 3,500 times 12, then divide by 400.
Okay, and then divide by
Huh?
105.
105, so we would predict that there would be 105 defective bikes in a batch of 3,500. Okay, any questions? Yeah? No? Okay, let's try a couple more. So I want you guys to try these and then we'll check back and see what you guys got. Okay, so for this one, we have 7 defective phones out of a batch of 118. We always put defective on the top, total on the bottom, equals X over 500. When you do this on the calculator, you're multiplying the two numbers that are across from each other and then dividing by this number. Hillary?
Okay, so I multiplied, in my head I multiplied 7 and 500 and I got 35,000.
Okay, 35 or 3,500, 3,500.
Yeah,
Okay, and then you
and then I
divided by.
divided by that and got 29.6 repeating, but then I rounded it up to 30.
Okay, so you get 29.6 repeating, but because we're talking about iPhones, we're going to round it to the nearest whole number. So we're going to say that X is about equal to 30 iPhones.
Wait, what? Is there something special about when you did that?
A little curvy equal sign means about. It means it's not exactly equal, but it's close.
So like if the beginning's curvy,
Wait,
then that's
one
not.
might, so the one, the home button or
Never
something
knew that.
might not work, because then it's not like the full thing's broken, but it's partly broken.
No, it's just if anything on it's broken, it goes in the bin as
A
defective.
smash.
Okay.
Would you
Jenna.
divide 7 and 118? Because I did that and got 0.05 and I put
And then you
Yeah.
multiply 0.05 times 500.
what?
Did you multiply 0.05? Oh, okay, you found the probability. So the probability is 7 divided by 118. Probability, you would actually round to 0.06 because it's 0.059. Okay, so the probability that a phone will be defective is 7 divided by 118, which is 0.06. So it's unlikely that a phone is going to be defective. Okay, Jace, how should I set this one up?
You put 6 over 25
Good.
equals X over 250. You're gonna do the rest?
Yeah, keep going.
Okay, and then you do 6 times 25.
6 times 25, no, I want to do
250. My
6
bad.
times 250, good.
And then you divide it by 25.
Okay, and what do you get?
And then you get X equals 60.
X equals 60. So we would expect that 60 of the candies would be yellow. Jenna, you want to tell us the probability?
0.24.
Okay, to find the probability that a candy is going to be yellow, we're going to do 6 divided by 25, which is 0.24. So it's unlikely that a candy is going to be yellow, but not hugely unlikely. It's 0.24, so it's not like almost a 1 out of 4 chance. Okay, I think that's where we're stopping for today. Yeah, we're going to stop there for today.